Hello, welcome to the Locust Electronics channel. Today I'm taking a look at capacitive touch sensors. The two most popular modules seem to be the tiny red PCBs and the bigger blue ones. I don't recommend buying the blue modules, since the one I got was defective and didn't react to touch until I bridged two pads with a blob of solder. Perhaps the PCB was made for a different integrated circuit? The red modules are much cheaper and they are working perfectly. By default they have a very tiny sensing distance. You have to touch them in order to trigger them. After all, they are touch sensors, so there is nothing wrong with that. Additionally, their range can be very easily extended by increasing the active sensor area. It's even more sensitive if you also touch the ground pin at the same time. It also draws a very tiny amount of current. Without the LED on, which draws about 5 milliamps, it draws only around 7 microamperes, and after a while of not being touched it automatically switches itself into a low power mode, in which it only draws up to 3 microamperes. So I scraped off some solder mask from the active sensor area, prepared some insulated wire and terminated the blind end to prevent any non-capacitive coupling for a good measure. A small wire for ground and a much longer 2-wire cable for the sensing area. And yes, it's the area what matters most here, rather than good electrical conductivity. I temporarily soldered a tiny LiPo and the switch for both power and the ability to power cycle it. And surprise, the device doesn't react to touching the sensing wire at all, but triggers whenever I bring my hands close to the rest of it, as if the roles of the sensor and ground have been swapped. This is exactly what the smaller ground reference wire is for. So I soldered it to the ground pin and wrapped the device in thermo shrink tube, ready to take it outside. I couldn't find a shovel, so I didn't properly ground the device, and therefore the results were far from perfect. In the real test, in order to determine if it could be of any use in measuring the popularity of trails in Swiss forests, I would place the sense wire in a plastic water pipe with sand and electrically earth the sensor ground with a reasonably sized steel or aluminum electrode. An optional ceramic capacitor shouldn't make much difference and may help in case you're worried about electrolysis. Maybe Andreas would like to test it? Even with all the room for improvement, I got some very satisfying results. The sensor clearly reacts to a human foot and bicycle wheels. I'm not sure if it will be able to detect fast-moving bikes, so probably the most optimal placement would be near junctions and sharp turns, where cyclists are likely to slow down. Back in the lab, my curiosity made me check one last thing about these sensors. How will they react if I connect the two wires of the cable to ground and sensor pad? As expected, the capacitance between the two wires was so high that it became very difficult to significantly influence it. I had to either pierce the insulation with a knife or touch the cable with both hands at the same time to get it to trigger. I hope you found this video useful or at least interesting. Have a good day. Bye!